Hi everyone, welcome to this short video on ASME GDTP-Technologist level certification program. The training exclusively organized by IMTMA. Myself, I'm Krishnamurthy M, the faculty for this program. What is the objective of this program? This program will equip the participants with the complete knowledge about GD&T as per ASME standards, right from the fundamentals up to a level of undertaking the GDTP certification examination by ASME. The duration for the entire program would be about 22.5 hours, and the entire program will be delivered in the online mode, and it is divided into 6 sessions of over 5 days. This program will be based on the ASME GD&T standard of version 2009. Some of the unique features about this training program will be using the course material directly from the source, that is from ASME, and a copy of the training material will be handed over to the participants at the end of the session for their future reference. And the participation certificate, we call it as a gold seal certificate, will be directly delivered from ASME at United States. And during the training period, the participants will be provided access to ASME Y14.5 standards for reference. And through the various presentations and case studies, the participants will be able to know the applications of various GD&T controls for new product development, for quality assurance or quality control, as well as production and manufacturing engineering, and all the allied functions in a manufacturing industry. Yet another important aspect of this training program is about the preparation for the ASME GDTP certification. And this training will also include a mock test so that the candidates are getting prepared for the ASME certification examination. And there is also a provision of complimentary ASME membership for non-members. And yet another important feature is that the presentations will be supported by live video demonstrations about the inspection and validation of all the GD&T parameters by using a conventional setup, what we call from the first principles or the benchwork method, as well as by using a coordinate measuring machine, CMM, as well as functional gauges. In this way, the classroom sessions with the support of the practical video demonstrations will enable the understanding becomes complete for all the participants. And the faculty, in this case myself, I am the authorized training instructor, ATI, on behalf of ASME, and I am authorized to deliver programs on behalf of ASME in India for both technologist level as well as senior level certification programs. I had completed my senior level examination, GDTP examination, and I am a certified senior GDTP professional. The benefits to the participants include a complete understanding of GD&T right from the terminology and up to the 14 parameters. And what is the relationship between the various controls and the terms, including RFS, MMC, LMC, then RMB, MMB, as well as LMB. And interestingly, when to use what control, which forms the important aspect of the entire GD&T domain. We will go through a approach. We will go through a structured approach while discussing about datums. That is nothing but datum reference frame, or in short DRF. What are the requirements of datums? How the datums constrain the degrees of freedom, all the aspects. Then practical inspection of GD&T controls. Then case studies to understand the application of GD&T parameters from a designer's perspective. Then what are the standard rules as per ASME Y14.5? Then tips and tricks for preparing for the ASME certification examination and complementary membership. The course coverage would include a complete familiarization with the various terminologies, then the datums, then the individual parameters coming under the group of form parameters, orientation parameters, profile parameters, location group of parameters, as well as in detail about the importance of position tolerancing. What do you mean by composite position tolerance? What are their applications? Then lastly, on the runout group of parameters. About the importance of GD&T, it's a well-known fact that proper implementation of GD&T in the right manner will enable cost reduction in the manufacturing, as well as what you call lead time reduction in the entire cycle of design through manufacturing. And since GD&T is a common language across the entire value chain, that means within the functions in a manufacturing organization, as well as across customers on one side and suppliers on the other side. And today, the understanding of GD&T is more and more important as the customers and suppliers are located throughout the globe. And yet another important aspect which is noteworthy is that proper understanding of GD&T enables an effective cross-functional team approach, CFT approach, involving various functions within the manufacturing organization. Thereby, the better design can be evolved and day-to-day challenges can be addressed and solved, so that the entire lead time in design through manufacturing can be reduced, which is ultimately leading to cost reduction. To whom this program would be applicable? We can say in a nutshell, this program is applicable across the organization since it is an international language, and it is applicable to engineers and executives, junior to senior level management professionals from all the functions, right from design or R&D and new product development, production engineering or manufacturing engineering, then the production and assembly, then quality assurance or quality control, then sourcing and service and application. So thereby, GD&T cuts across multiple functions within a manufacturing organization. And as such, thorough knowledge in GD&T is essential so that meaningful communication can take place between the suppliers and customers, and within multiple functions within an organization. And this program is not only for manufacturing organizations, it is also applicable for engineering service providers, where they undertake value-added services, right from new product development or changes in the design, updates in the design, where their customers could be located anywhere else in the globe, and the engineering service providers located in India are extending their services in various design and development and engineering functions. And another group of people to whom this program would be strongly suggested is for those engineers who are aspiring to get certified by ASME as a GD&T technologist level professional, with their names appearing in their ASME website, and they are globally recognized as GD&T certified professionals. About IMTMA, Indian Machine Tool Manufacturers Association, established way back in 1946, is an authorized training provider, ATP, for ASME, and IMTMA is certified for providing ISCET accredited ASME training courses on this particular standard, that is GD&T Y14.5, for engineering professionals across the country. And IMTMA has a state-of-the-art training facility called as Technology Center, located at Bangalore International Exhibition Center in Bangalore, with complete CNC machines as well as metrology lab supported with CAD/CAM, CAE, and all the other accessories. And IMTMA, we have trained more than 2,000 plus professionals in GD&T across the country, from all the functions of an manufacturing organization, as well as engineering service providers, as well as aerospace industries. And the training methodology is unique in the sense it is the classroom sessions are supported with live demonstrations, as well as workbooks and group exercises, so that the understanding becomes complete. And at the end of the training program, the participants can really in a position to implement the GD&T standards in their own projects. And quick word about the GD&T certification from ASME. As all of us know, ASME is the originator of GD&T standards, and the first standard in Y14.5 has been published in the year 1994. Prior to that, it was called as ANSI, ANSI 1982 version. And in order to give global recognition to the trained professionals, ASME has come out with professional certification in 2 levels. The first level is called the technologist level, and the second level is called the senior level. And both the levels will bring in global recognition for the organization across the customers and suppliers, then at an organizational level. And secondly, for the participants, it again brings a global recognition leading to their further career growth. Let us talk about how GD&T is applied in a manufacturing organization. Today, we live in an era of concurrent engineering rather than sequential engineering. And concurrent engineering philosophy involves the coordinated approach across multiple functions, including design, tooling, then manufacturing, assembly, as well as quality, so that the entire lead time of design through manufacturing is reduced and the complete design becomes sort of error-free, so that there are no challenges in the downstream applications, right from tooling, manufacturing, quality, etc. So thus it involves a cross-functional team approach so that the challenges are identified at the design stage itself and countermeasures have been incorporated at the beginning before the design is frozen and released to the downstream applications. Here, GD&T plays a huge enabling role so that the communication of the designer, the intent of the designer is well communicated across the multiple functions within the organization and then again across its suppliers as well. And the concurrent engineering or the simultaneous engineering is active dialogue, communication in two-way communication between the concerned departments so that the lead time is reduced and the further challenges are minimized or nullified. And as all of us know, the purpose of engineering drawing is effective communication of the entire data, including the geometry, functional relationship, tolerances, plus the peripheral information, material, heat treatment method, coatings involved, etc., along with the documentation terminologies. For a moment, let us imagine if the GD&T symbols are not there, which are shown in the last column, whereas the communication happens in a particular language, in this case Chinese, then how the activities can be carried out across in a global manner across multiple customers and suppliers located throughout the globe. In this particular slide, the wordings are in the explanation is in Chinese. However, if you are not comfortable in understanding the Chinese language, then we don't have any clue what is meant in these wordings, right? Whereas the same information, if it is conveyed through the symbols as listed in the last column, then the understanding becomes universal in nature and there is no need for any text, any communication in a given language, any communication in the form of a text. So that is the power of GD&T, which is again a universal language, and be the customer or be the supplier, be located anywhere in the globe where multiple languages are spoken and communication always becomes a bottleneck, understanding becomes a challenge. The communication using symbols is quite powerful. All right. So in GD&T, these 14 symbols, each of these 14 symbols convey a particular meaning, and we'll be dealing with the complete terminology right from the first symbol to the last symbol. So in other words, GD&T is the international language that is used in the engineering drawings so that the part is described in an effective manner, in an accurate manner. And what is described? This information regarding the size, information regarding the form, information regarding the orientation between the features and location between the features. This information is precisely conveyed using a well-defined set of symbols, which we call it as the GD&T standard, accompanied by certain rules, definitions, as well as conventions, which will be taken up in detail in this training program. This slide talks about what could be the challenges in case if the drawing doesn't contain any GD&T symbol. This drawing contains all the dimensions with the dimensional tolerances. However, there are no GD&T symbols. Whereas a better approach would be to change the drawing with the concerned GD&T symbols so that the assembly takes place in a seamless manner without any challenges. And our entire discussion will be based upon ASME Y14.5 standard as per the version 2009. And we'll also highlight about the related standards, including 14.41, 14.5.1, and 14.43 as well. And I think some of you would be familiar with many of the symbols, or some of you would be familiar with few symbols at least. Whereas in our discussion, we'll be going through each of the symbol in detail with respect to their application. And the first 3 rows are called the main symbols. And there are few modifier symbols. There are few additional symbols. We will understand the application of understanding them. You will have a complete understanding of the meaning of each as well as the application with engineering examples. And we will also go in detail to understand what is rule 1, or in other words, envelope principle, why ASME standard specifies rule 1, why it is necessary, and what is its functional importance. What is the logic of having rule 1 from here? With an application example, let us discuss and understand in detail. Similarly, what is rule 2? What are the various terminologies associated with the rule 2, including RFS, MMC, as well as LMC conditions? Then interestingly, we will move on to discuss about the datums and how the datum reference frame, DRF, consisting of primary, secondary, and tertiary datums, constrain the degrees of freedom. For a given part, how many datums are required to constrain the degrees of freedom? Then which datum should be assigned primary, which datum should be assigned as secondary? From a functional point of view, we will discuss few case studies like the one shown in the example. And we will also understand the need of datum targets. What is the difference between datums and datum targets? How to specify datum targets in a drawing. As we keep discussing the individual parameters, right from flatness to runout to profile tolerance, we will have a summary, and at the end of each group of parameters, which is summarizing the application to which group of features the concerned parameter is applicable. Is it a feature of size or is it a non-FOS? Is MMC symbol is allowed with the particular parameter or not? So our summary will involve all these aspects so that the understanding becomes clear and we will be in a position to apply the GD&T parameters, select and apply. When it comes to position tolerance, which is an interesting parameter out of the entire GD&T spectrum, we will understand how the philosophy of position tolerancing is different from a regular coordinate tolerancing method and how we get an extra tolerance when we change the tolerance zone from a square shape or rectangular shape to a circular shape, like the one indicated in the blue color. Then what is meant by bonus tolerance, when it is applicable, and how do we get extra tolerance as shown in the green color. We'll also dwell upon what is called zero position tolerance. Is it right one? Is it advantageous when we can go for using zero position tolerance at MMC? We'll also discuss a couple of examples on using L symbol, which is a bit rare in the GD&T usage, the GD&T applications. But still, for controlling the wall thickness applications, how LMC modifier has to be used and how we can use the LMC modifier. Then similarly, what difference it brings in when you have modifier symbols next to the datums. Whenever you use a modifier symbol next to the datum, we get what you call datum shift. So what is the meaning of datum shift? How it is different from bonus tolerance? These aspects we'll be discussing at length. Then we'll also talk about how to calculate the position tolerance based upon the assembly situation, what we call floating fastener or fixed fastener. Then along with position tolerance, there is a possibility to use a modifier symbol called P, meaning projected tolerance zone. We'll discuss about that. Then in GD&T, especially in position tolerance, there is an interesting aspect called composite position tolerance like this. When to go for composite tolerance, what are its significant benefits, what is the meaning? Let us discuss more in detail. Here, an interesting application of composite position tolerance is highlighted to control the coaxiality of the holes. Then we will summarize at the end of each group of parameters. Then when we talk about profile tolerancing, we'll also highlight and understand what is meant by composite profile tolerancing and what are its applications. How profile tolerances, especially composite position profile tolerance, can be used to control size, form, orientation, as well as location. In other words, the powerful nature of profile tolerances we'll be able to understand and use it in our day-to-day designs. And coming to runout, we'll understand both circular runout as well as total runout with multiple examples along with summary. So in this manner, this training program will address all the aspects of GD&T, right from the fundamentals, terminologies, the related parameters, rules and conventions, datums, Then the 14 parameters with multiple examples as well as supported by live video demonstrations. So I invite all of you to participate in this program, both from the organization point of view as well as career growth perspective. And thank you for your attention. See you during the program.